One of the important things that we're going to talk about in chemistry is how to measure things. And so measurement is really an important concept. Every measurement that you make has two things. It has a number associated with it, and it also has a unit. And if you just give me a number and don't use a unit, it really doesn't mean anything. So if I have 325 of aspirin, okay, if I'm giving aspirin to somebody, 325 milligrams would be a whole lot different from 325 pounds. A fast time for a 100-meter dash would be 10 days or seconds. So it's very, very important that the unit accompanies that. And so when you're starting to work chemistry problems, one of the easiest things to help you get the right answer is to make sure you always write the units down when you're working those problems. So the measurements that we use typically in here are going to be metric. And so you're going to have a base unit in the metric system. So for length, we use the meter. For mass, we use the gram. Volume, we use liters or sometimes milliliters, but that's the base unit. And then for second, we use time to measure that. So that's one that we're used to even if we don't understand the metric system. Other units are going to be relating the base by a power of 10. And we use prefixes to do that, and that indicates if the unit is larger or smaller than the base unit. For example, giga, mega, and kilo are big, okay? If you ever watch the cop shows, they got a kilo of cocaine or whatever, okay, you know that's big, right? That's bigger than a gram or whatever we're talking about. If you have a gram, it's going to take 1,000 grams to equal 1 kilogram because a kilogram is larger. But if I have a milligram, it's going to take 1,000 milligrams to equal 1 gram because it's 1,000 times smaller. So a kilo is 1,000 times larger than the gram. The milli is 1,000 times smaller than the gram. And they've also given you your scientific notation numbers here to help you as well. So you definitely are going to see kilo and centa and milli a lot in this course. So at the bare minimum, you need to know those, okay? Now on your exams, you're going to be able to use a note card. So make sure that if these are things that you don't remember, then you might want to put those on there. So if you have a base unit of length as the meter, if you have 1,000 meters, that's the same thing as 1 kilometer, or we usually just call it a kilometer, right? If you have 1 millimeter, that's going to be 0.001 meters. Or the other way to think about that is you have 1,000 millimeters in 1 meter. Since centa is 0.01, you have 1 centimeter in 0.01 meters, or that's the same as saying you have 100 centimeters in 1 meter. Okay, so whichever way you want to think about it, I like whole numbers, so that's why I kind of look at it the other way. So mass is the amount of matter that we have. Weight is gravitational force. Okay, so how much gravitational force there is due to that amount of matter. Okay, so the reason they're different, if you think about it, is the gravitational force on the Earth is a lot stronger than that on the Moon. And so I would always have the same mass whether I was on the Moon or whether I was on the Earth. But my weight would be different because since the pull of gravity is more on Earth, I'm going to weigh more on Earth than I would on the Moon. All right. Now we use those terms interchangeably a lot, and we say it weighs this, it weighs that. We'll put it on the balance and do that, but we're really talking about mass. And the base unit of mass is the gram, but you can use those same prefixes. 1 kilogram is 1,000 grams. 1 milligram is 0.001 grams. Or remember, the way I kind of turn it around is 1,000 milligrams is 1 gram. The base unit of volume is the liter, and you can have a kiloliter, which is 1,000 liters. You can have a milliliter, which takes 1,000 of them to make 1 liter. And then the other thing you can have is a cubic centimeter. A cubic centimeter is equal to 1 milliliter, and you may have even heard it called a cc. That's what they used to call it a long time ago in the medical profession. Most people that were brought up in the olden days still say it, but they're really talking about a milliliter now. Since we live in America, we have to convert our English units to metric units because we don't do English units in science. And so until we decide to convert everything to the metric system, which probably will never happen, we in science have to do those conversions. And so we use these conversion factors because we know that in 1 foot you have 12 inches. That's in English. In the metric system, 1 inch is the same as 2.54 centimeters. All right, so a lot of times you're going to have those conversion charts for your test, but just look and make sure. You really should know some of these. If you have a TI-83 or TI-84 calculator, they actually have a lot of these conversion factors in there. But you've got to be able to do that, in your head or on paper as well. So what I find, which is really funny to me, is that most of the time people are okay with the metric English relationships. They can't remember these. They can't remember how many ounces are in a quart and things like that. So we always want to keep our English units, but then we don't even know because they make a lot more sense. You've got 1,000 in one or 100 in one, those nice round numbers, instead of 2,000 pounds in a ton, 16 ounces in a pound, things like that. So